Today we start our unit on solving quadratic equations. First, we're going to talk about the discriminant and nature of solutions and multiplicity. Just for a quick review, a quadratic equation's solutions when f of x equals 0 are also its x-intercepts, roots, zeros. So let's take a look at the solutions for the three following quadratic equations. For number 1, when we graph this, we see that it goes through the x-axis at two places. So we have two solutions where it crosses the x-axis. And those solutions are at -3 and +4. For our second equation, when we put this into Desmos, we see that it touches the x-axis, but does not go all the way through. And so it only has one solution where it's on the x-axis at -5. For our last equation, when we graph it in Desmos, we see that it doesn't touch the x-axis at all. So it has no real solutions. It never touches or crosses the x-axis, so our solution would be the empty set. Now, we looked over these last week. However, with this last one being the empty set, no real solutions, if you recall, I mentioned we'd talk about those later. Well, later is now. So we are going to start talking about how do we find those non-real solutions. And to start with, we're going to look at the discriminant. So before we do, let's talk. We were always taught we could not take the square root of a negative number. So if you put -1 under the square root sign in a calculator or in Desmos, you get an error. Now, we have a new number system that we're working with called the complex number system. We can do that by using what we call the imaginary term, or otherwise known as I for short. So our square root of -1 is I. So in looking at the numbers we've dealt with so far this year, we've done natural numbers, 1, 2, 3, 4, 5, and so on. Those are your counting numbers. Whole numbers, add in 0. Integers, add in your negative numbers. Then you have your rationals, which are fractions and repeating decimals. And you also have irrationals, so square roots, non-repeating decimals, and pi, for example. And all of those are combined to form the real number system. So those are what we've worked with so far. But now we're adding in our imaginary numbers. So I, or 2 times I, or 2 plus 3i, and that's in what we call the complex number system. So we're going to pause on that for a little bit, but we are going to come back to it again with our next lesson. And in the meantime, let's go ahead and look at the discriminant. The discriminant is a portion of the quadratic formula, and that determines the number and nature or type of solutions for a quadratic equation. So our discriminant is actually the portion of the quadratic formula under the square root. This is where I comes in, because if the discriminant is negative, that would be imaginary. We'll talk about that a little more in just a moment. So our discriminant is just b squared minus 4ac. It's what's underneath the square root, and it's what is added and subtracted to the rest of the quadratic formula. And we find our a, b, and c by looking at our original equation. And it's in the form of ax squared plus bx plus c equals 0. And a is not equal to 0, meaning x squared is there, and you have a number in front, or it could be a coefficient of 1 in which you may not see it. So our a is going to be in front of x squared. Our b value will be in front of x, and our c is our constant, or our number at the end. Our discriminant just puts underneath the square root symbol, b squared minus 4ac. Now, to find this for a, b, and c, remember it does have to be equal to 0. Otherwise, this formula doesn't work. So let's see this in action. Now, a positive discriminant. So that number is greater than 0. What that means is, for the rest of the quadratic equation, you are adding and subtracting a real number two real numbers, and so your answers or your solutions will be two real solutions. So remember, our real solutions look like something like this, where our parabolas go through the x-axis 2 times. Now, if our discriminant is 0, meaning you're adding and subtracting 0, so that's the same number, you're not changing anything, that's where you get one real solution. This is where we've seen our double roots before. Our graphs would look something like this, where our parabola comes down, touches the x-axis, and then changes direction. So it is on the x-axis, but does not go all the way through it. Now, if we have a negative discriminant, b squared minus 4ac is less than 0, then that would mean you're taking the square root in the quadratic formula of a negative number. And that means you would have two imaginary solutions, or no real solutions. And that would be where our graphs look something like this, where the parabola never touches the x-axis. So, given the discriminant, we should be able to figure out how many real and how many complex solutions each quadratic equation has. For a discriminant equal to 37, that's greater than 0, so I know I have two real solutions and no complex solutions. If my discriminant is negative 12, then I'm taking the square root of a negative number, that's where I comes in, so I have no real solutions and two complex solutions. If the discriminant is equal to 0, well, that means I have one real solution, that's my double root, and no complex solutions. All right, you try these last two. Pause the video and then check your answers. All right, so with a discriminant of negative 8.5, since it is less than 0, you should have 0 real solutions and 2 complex solutions. For a discriminant of 7.2, it is positive, so you have 2 real solutions and 0 complex solutions. So let's actually try to find the discriminant of some quadratic equations. If we look at our first one, we have x squared minus 8x plus 16 equals 0. So our a value is the number in front of x squared. And if we don't see it, remember that could be just 1, because we usually don't write 1x squared. So our a value here is 1. Our b value beside x is negative 8. So if I have a minus sign, I keep that sign with it. So b is negative 8. And our c value is our constant, or our number that's not beside x, and that is plus 16, or positive 16. So I'm going to write out b squared minus 4ac, and I can plug in my numbers. So b is negative 8, and I put everything in parentheses. So negative 8 squared instead of b squared, minus 4, a, which is 1, c, which is 16, and I can plug that into Desmos just like I see it there. Or the other option is to write a equals 1, b equals negative 8, c equals 16, and then type in b squared minus 4ac, in which case it still finds your answer there by substituting those numbers in. So whichever way you opt to put it into Desmos, you get back 0 for this one. So since our discriminant equals 0, that means we have a double root, or one real solution. For our second one, here a is negative 5. B, our number in front of x, remember if we don't see 1 there, that means the coefficient is likely just 1. And we have our plus 1 at the end. That's our c value. So I write out b squared minus 4ac. I plug in my numbers, 1 for b, 1 squared, minus 4, a, negative 5, c, 1. I plug that into Desmos, either as I see it or with a equals b equals c equals, and then b squared minus 4ac, and either way, I get 21. 21 is greater than 0, which means I have 2 real solutions. All right, now you try. Pause right here, plug in your a, b, and c values, find your discriminant, and then hit play for your answers. Alright, so we should have found that A is 8, B is 8, and C is 3. We write out B squared minus 4AC. Plug it in, 8 squared for B squared minus 4. A, 8. C, 3. And plugging that into Desmos, we get back negative 32. Since we have a negative number, our discriminant is less than 0, so we have 2 complex solutions, or imaginary solutions. On number 4, we don't see a coefficient in front of x squared. That means it is just 1. We have a 7 in front of B, and positive 11 here at the end. That's C. So we have B squared minus 4AC. We plug it in. B is 7. 7 squared minus 4. A is 1. C is 11. Plug it into Desmos, and we get back a positive 5. So our discriminant is greater than 0, so we have 2 real solutions. So now what do we do if the equation isn't equal to 0? Well, we have to fix it. So in this equation here, I have x squared plus 3x equals 2. So what I want is the 2 on the other side. And in order to move it, I just move it to the other side and change the sign. What I'm really doing is subtracting from both sides, but moving and changing the sign is just as easy. So my x squared plus 3x will come down. My 2, I'm going to change sides and sign. So I make that minus 2, and then I can set it equal to 0. So now I've got my a value, and since there's nothing in front of x squared, I know that that's 1. I see that b is a positive 3, that's in front of x, and our c value, the number by itself, is negative 2. I can write out b squared minus 4ac, replace my numbers. B squared is 3 squared minus 4. A is 1. C is negative 2. And that equals positive 17, which is greater than 0. So I have 2 real solutions for this one. So you try this next one. However, first, let's take a look. I'm going to help you out a little bit on number 6. You notice here we have 10x on the other side of the equal sign. So when I move it and change the sign, I keep my x squared plus 18. 10x becomes negative, so minus 10x equals 0. Now, remember it's ax squared plus bx plus c. So I usually write them in order. B is beside x, so if we rewrite in order, that does help. So I'll keep x squared minus 10x plus 18 equals 0. Now, go ahead and find a, b, and c. Find our discriminant and number and nature of solutions for 6 and for 7. Pause here and hit play when you're done, and we'll check our answers. All right, for number 6, we should have that a is 1, b is negative 10, c is 18. And when we plug those into b squared minus 4ac, we get negative 10 squared minus 4 times 1 times 18, which is 28. And since it is positive, its discriminant is greater than 0, and we have 2 real solutions. For number 7, we want to move both of these numbers, so we get x squared minus x minus 30 equals 0. So our a is 1, our b is negative 1, and our c is negative 30. Write out b squared minus 4ac, plug in our numbers. B squared is negative 1 squared minus 4, a 1, c negative 30, which gives me 121, which is positive, so our discriminant is greater than 0, and we have 2 real solutions. All right, our last concept talking about today, we have broached a little bit on this subject in the past, is multiplicity. So remember, the multiplicity of a root or 0 is the number of times an equation has a root at that point. So we identify multiplicity as either 1 or greater than 1. So in our graph shown, we want to identify the multiplicity of each 0. So we have a 0 here at -1. And because it is touching the x-axis, it does not go through, but it touches and then changes direction, our multiplicity is greater than 1. If we know we're dealing with a quadratic, then we can say our multiplicity is 2. But if you're not certain, we just say multiplicity is greater than 1. Now, our other 0 is here at x equals 2. And that goes through the x-axis. It's not just on it, but goes all the way through. So our multiplicity is 1. All right, couple of practice problems. Number 1, which 0 has a multiplicity greater than 1? Pause it here. We'll check our answer when you hit play. All right, so here we are looking for something that is on the x-axis and not going through it. And the only 0 we have on the x-axis is at +2. So here at +2, we have a multiplicity greater than 1. Now, here, for number 2, we have a function has a discriminant of -12. Which one is true? Pick your answer, hit play when you're ready. For number 2, we have a discriminant of -12, which is less than 0. Since our discriminant is less than 0, we know that our solutions have to be complex or imaginary. So I'm going to pick answer choice B.